Alright, hello. So let's look at an example of a hypothesis test for matched pair samples. So this means that it's some sort of study or experiment done on like the same group of people or related groups that are related to each other. It's often that you are comparing performance of the same group in two different conditions, two different settings, okay? To kind of see if things are one way is better than the other or that they're different. Okay, so question 1 here is the average time to complete an obstacle course shorter when a patch is placed over the right eye than when a patch is placed over the left eye? So 13 randomly selected volunteers first completed the obstacle course with the patch over the right eye, and then same people, equally difficult course with the patch over the other eye, and the completion times are shown below. And right means the patch was placed on the right eye, left means the patch was placed over the left eye. So kind of the important thing is that it's the same participants. So it's not two independent groups, it's dependent, it's matched pairs, right? So assume it's a normal distribution. What can be concluded at the alpha is 0.01 level of significance. All right, so for this one, we're going to use a t-test for matched pairs. Alright, okay. So the null and alternate hypotheses would be that the mean times are equal, right, for the two groups. So you can have mu1 is the right and mu2. Group 1 is the right eye, mu2 is left eye, right? And the alternate is, are we trying to see if they're... Right, so the average time to complete the obstacle is shorter when it's placed over the right eye. Okay, so we want mu1 to be less than mu2. So the right group has a smaller mean, so shorter time than the left group. Alright, so we got to do our statistics. So we need to put these numbers in. Okay, so let's get a new data table, and we're going to, what do we need to type? We have right and left. So right and left. Alright, we gotta type in the times. I'll do that while I'm paused. Alright, so here's our data. I think there is a little error in the problem. It's not going to make a difference when we do it. But it said like 13 selected volunteers, but it's only 1, 2, 3, 4, 5, 6, 7, 8. So this should be 8. Right? But the program is going to read that there's 8 data sets. So it's not going to use 11 and 13 anywhere. Okay? So we're going to go to stat and t-stats paired. Okay, so we're going to use paired. Right? So sample 1 is in column right and sample 2 is in the column left. And here we want mu d is the mean of the difference, is 0. Right? And the alternate, so we want basically to test if the first mean is less than the second mean. So if I take the difference between the first mean and the second mean, it would be a negative number if it was smaller. So we want the mean of the difference to be less than 0. Okay? We click compute and we get this stuff. So we get a t-stat of negative 1.50. Alright, so t-stat is negative 1. I forgot already. 0.50. Right? And the p-value is 0.1643. Alright. Okay, let's do the graphing calculator so we can compare. Just let me give me a second to pull it up. There it is. Alright, so let me see my data. So we're going to do second quit to get back. Let's do stat and edit. And we want to put our data in the first and second columns. So we're going to clear this. Clear and enter. Alright, so we gotta type in 49, 44, 42. Alright, here we go. So the data is all type 10 in the first and second columns. Okay, so now you want to do second to mode to quit it, go back to the initial screen, then we go back to stat and to tests. Alright, so now we need let's see. Oh, there you go. So we're not quite ready to do the test yet because the graphing calculator doesn't have a test for matched pairs. You have to do a t-test on the difference between the columns. So what we want to do is go back to the editor. So I have our two columns in here, the right and the left. In the third column, L3, we want to find the difference between these. Okay, so basically we're going to hit the arrow so it highlights the title, L3. And you're going to say L1 minus L2. So L3 equals L1 minus L2. So to find the L's are here. You see them in blue. So the second one gives me L1. Then minus second 2 gives me L2, and you hit enter. Alright, so this finds the differences between all these values, like 49 minus 50, 44 minus 44. You can do that by hand too, but you can do it with the calculator also. Alright, so now we're ready to run the test. Okay, so we're going to go to stat. We're going to go to tests, and we're just going to do a regular t-test, but on the column that shows the difference. We're going to do a t-test with data. All right. We want to test to see if the mean is the same, so the difference in mean is 0. All right. We're not going to use list 1. We're going to use list 3 because list 3 has the differences in it. So we're going to do second 3 to type in list 3 there. All right. And we want to see if it's less. All right, so we want to see if the first mean is less than the second mean, so we choose the one that says less. All right, and then we're going to calculate. All right, so we get a t-value of negative 1.050, which we got with StatCrunch, a z-value of 1.643. All right, yay, perfect. All right, cool. So now we're going to draw some conclusions here. Or make some decisions, draw some conclusions. Right, so the p-value is bigger than the alpha value, right? The alpha value is 0.01. Right, that means we failed to reject the null. Right, which means failing to reject the null means that there's insufficient evidence. It's statistically insignificant. That's what you're looking for. So the results are statistically insignificant at that significance level. There is insufficient evidence to conclude the population mean time to complete the obstacle course with the patch over the right eye is less than the population mean time to complete the obstacle course with the patch over the left eye. So it's this first one. So yeah, it's not significant because you're not rejecting the null. And this one, it says it's statistically significant, which is there's no evidence, right? So they kind of go statistically significance. There's insufficient evidence. Okay, when you fail to reject the null. All right, that's it.